At 6 p.m., a deceased body is found with a temperature of 80 degrees. An hour later, the body temperature has decreased to 75 degrees. The room the body was found in was 70 degrees. What is the time of death? So first we're going to write this equation that we know from the Newton's law of cooling, which is the temperature equals this T of S plus T of O minus T of S times e to the negative kt. So we're going to plug all this in, and first we're going to write what we know. So we know at 6 p.m. it was 80 degrees. And an hour later, which would be 7 p.m., it was 75 degrees. And the surrounding temperature of the body was 70 degrees. So when we plug that in, we'll do it at time equals. So basically this is T equals O, and this is T equals 1. Or 60, because we're going to do it for minutes. So when the body equaled 75 degrees, the surrounding temperature was 70 plus the starting temperature minus the surrounding, e to the negative k times 60. So then when we simplify this a little bit more, subtract 70 from both sides, we get 5 equals 80 minus 70 is 10, e to the negative 60k. And now we're going to divide by 10, so we get 1/2 equals e to the negative 60k. And now we want to get rid of this e so we can find k, which is our constant of proportionality. And when we do that, we're going to take the natural log of both sides, and this just equals 1. So then we have the natural log of 1/2 equals negative 60k. So then when we divide by 60 and we type it in our calculator, find out that k equals negative 0.0116, about approximately. So now that we know that, we're going to plug this in to another equation, the same one, but instead of finding k, we're going to find t. So since 80 degrees is the closest temperature to the normal body temperature, which is 98.6, we're going to use this one as our temperature. So we're going to have 80 equals our surrounding temperature plus our original temperature, which is 98.6, because that's the temperature the body was at before it deceased. And then we're going to subtract it by the surrounding, e to the negative 0.0116 t, because that is our k, which up here, constant of proportionality. So when we subtract 70 from both sides, we get 10 equals, this will be 28.6 e to the negative 0.0116 t. Now we're going to divide by 28.6, so 10 over 28.6 equals e to the negative 0.116 t. We're going to take the natural log of both sides. Natural log of e is just 1. So and then we divide by this negative 0.116 to get t equals 90.59 minutes. So this is the time it took for the body to get from 98.6 degrees to 80 degrees when we found it originally. So to find the time of death, we're going to find that time we found it, 6 o'clock, subtract it by this time, which is 90.59 minutes. And to do that, we're just going to make that 91 minutes. So when we subtract 91 minutes from 6 p.m. at 5 o'clock,
the easier way to do it.
We still have at 5 o'clock, we still have 31 minutes. So it will be at 4:29 p.m. approximately at the body, which is the time of death.